What if one of the most beautiful fish in the ocean was also one of the most destructive? With its bold stripes, flowing fins, and venomous spines, the lionfish looks like it belongs in a royal aquarium. But beneath that beauty lies a silent killer that's changing entire ecosystems. How did this exotic predator end up thousands of miles from home? And why can't anything seem to stop it? The lionfish is a strikingly beautiful but dangerously invasive species, easily recognizable by its bold stripes, venomous spines, and fan-like fins that ripple like a feathered cloak in the water. Native to the Indo-Pacific region, lionfish have become notorious for their rapid spread and devastating impact on ecosystems far beyond their original range. With no natural predators in their new environments, particularly in the western Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico, lionfish populations have exploded, threatening native marine life and coral reef systems. Despite their appearance, these fish are ruthless predators, consuming vast numbers of smaller fish and crustaceans and outcompeting native species for resources. Lionfish belong to the genus Terroir, with the two most common invasive species being Terroir volitans, the red lionfish, and Terroir miles, the devil firefish. Both have similar appearances, featuring long, venomous spines and zebra-like stripes. These spines are not only used for defense, but also act as a deterrent to predators who might otherwise attempt to eat them. The lionfish's appearance serves as a warning to others that they are not an easy target. Though their sting is rarely fatal to humans, it can cause extreme pain, nausea, breathing difficulties, and even temporary paralysis. Divers and fishermen who come into accidental contact with a lionfish quickly learn to treat them with caution. Despite their dangerous spines, lionfish are graceful swimmers, using their large pectoral fins to hover and maneuver with precision. This helps them in their unique hunting strategy. Lionfish are ambush predators that use stealth and patience to approach their prey before striking with a sudden gulp. They often corner small fish and shrimp using their outstretched fins, gradually herding them into a tight spot where escape becomes impossible. Then, with lightning speed, they open their mouths and create a vacuum that sucks their prey in. This feeding behavior makes lionfish highly efficient hunters, capable of consuming prey up to half their body size. One of the most concerning aspects of the lionfish invasion is their reproductive capacity. A single female lionfish can lay as many as 2 million eggs per year, releasing large egg masses every few days. These eggs are encased in a gelatinous sac that protects them from predators and allows them to drift with ocean currents. This method of dispersal means that lionfish larvae can travel long distances, colonizing new habitats far from where they were spawned. Because lionfish larvae have a high survival rate and grow quickly, their populations can increase rapidly in favorable environments. In their native Indo-Pacific range, lionfish populations are kept in balance by natural predators and environmental pressures. However, in the Atlantic and Caribbean, where lionfish are not native, they have very few natural enemies. This allows them to thrive unchecked, consuming vast quantities of juvenile reef fish and shrimp that play vital roles in the ecosystem. As lionfish numbers increase, populations of native species such as parrotfish, snapper, and grouper decline. These species are important not only for maintaining healthy coral reefs, but also for supporting local fisheries and economies. By preying on these fish, lionfish indirectly contribute to the degradation of coral reefs, which depend on herbivorous fish to control algae growth. The exact cause of the lionfish invasion remains unclear, but it is widely believed that the species was introduced to the Atlantic Ocean through the aquarium trade. Accidental releases or deliberate dumping of lionfish into the wild may have occurred in the 1980s off the coast of Florida. From there, they spread rapidly, aided by ocean currents and their prolific breeding. Genetic studies of lionfish in The Atlantic have revealed low genetic diversity, suggesting that the entire invasive population may have originated from just a few individuals. This highlights the resilience and adaptability of the species, which managed to establish a foothold and expand its range despite starting with a limited gene pool. Efforts to control lionfish populations have included organized culling events, lionfish derbies, and targeted removals by divers. In some areas, local communities and conservation groups have embraced lionfish hunting as a way to protect reefs and promote environmental awareness. Because lionfish have firm, white meat with a mild flavor, they are increasingly being promoted as a sustainable seafood option. Restaurants and seafood markets are beginning to feature lionfish on their menus, encouraging fishing and consumption of the species. This approach serves the dual purpose of providing an economic incentive for control, while also educating the public about the ecological threat posed by lionfish. However, managing the lionfish invasion is a complex and ongoing challenge. Unlike terrestrial invasive species, which can often be controlled through physical barriers or chemical treatments, marine environments offer few practical options. Lionfish often inhabit deep or hard-to-reach areas where divers cannot easily access them. Moreover, their tendency to spread rapidly and reproduce frequently makes it difficult to keep pace with their growth. Some researchers have explored the possibility of developing robotic lionfish hunters or using attractant traps to catch them more efficiently. While promising, these technologies are still in development and may not be effective on a large scale. Without widespread deployment and community involvement. In addition to mechanical and human-driven control methods, scientists are investigating the potential for biological control through the introduction of predators or parasites. However, introducing new species into an ecosystem carries its own risks and could cause unintended consequences. So far, native predators like groupers and sharks have not shown a significant interest in eating lionfish, likely due to their venomous spines and unfamiliar appearance. Training native predators to recognize lionfish as prey has been suggested, but it is difficult to implement such behavioral changes on a meaningful scale. For now, human intervention remains the most effective tool in the fight against lionfish proliferation. Lionfish behavior also contributes to their success as invaders. They are bold and unafraid of humans, often allowing divers to approach closely. This makes them relatively easy to spear or net by hand, at least in shallow areas. Additionally, lionfish are active during both day and night and have been observed feeding at all times. Their opportunistic diet includes more than 70 species of fish and invertebrates, making them highly adaptable to different environments. This dietary flexibility allows lionfish to thrive in a wide range of habitats, from coral reefs and mangroves to seagrass beds and even ship recks. As lionfish spread across the Atlantic and Caribbean, scientists have observed changes in local fish populations and reef structures. In heavily invaded areas, there is often a noticeable decline in species diversity and abundance. Smaller fish that serve important ecological functions are especially vulnerable. For example, cleaner wrasses and gobies, which remove parasites from larger fish, are heavily targeted by lionfish. This disrupts cleaning stations and impacts the health of larger reef fish. Similarly, the loss of herbivorous species can lead to unchecked algal growth, smothering coral, and reducing reef resilience. These cascading effects highlight the far-reaching consequences of lionfish predation on marine ecosystems. Despite the ecological threat, lionfish are undeniably fascinating creatures. Their ability to thrive in a variety of conditions, reproduce rapidly, and dominate new environments makes them a textbook example of a successful invasive species. Their striking appearance and unusual hunting behavior continue to draw interest from scientists, divers, and the general public alike. In many ways, The lionfish serves as a symbol of how human activity can unintentionally disrupt natural balances and introduce new threats to vulnerable ecosystems. At the same time, it represents the potential for coordinated human action to mitigate damage and protect biodiversity. Public awareness and education are crucial components in managing the lionfish crisis. Divers and snorkelers are often the first to spot lionfish in new areas, making citizen science an important part of monitoring efforts. Apps and online databases allow users to report sightings, helping researchers track the spread of lionfish and identify hotspots. In some regions, schools and community groups participate in lionfish-focused programs that teach about marine conservation and invasive species. These initiatives help foster a sense of stewardship and encourage proactive measures to protect local ecosystems. There is also growing interest in developing commercial markets for lionfish products beyond food. Their ornate spines and distinctive patterns make them attractive for use in jewelry and decorative items. By turning lionfish into a valuable commodity, advocates hope to create sustainable economic incentives for harvesting them. However, care must be taken to ensure that these efforts do not inadvertently promote captive breeding or reduce the urgency of eradication. Balancing economic opportunity with ecological responsibility is key to long-term success. As global ocean temperatures rise and ecosystems face mounting pressure from climate change, invasive species like the lionfish may become even more problematic. Warmer waters can expand the range of tropical species, allowing lionfish to move into areas previously too cold for them to survive. Changes in ocean currents and storm patterns may also facilitate the spread of larvae to new regions. Combined with overfishing, pollution, and habitat loss, these factors create a perfect storm for ecological disruption. Managing lionfish populations is not just about protecting coral reefs today, but also about building resilience for the future. Understanding lionfish and their impact requires a multidisciplinary approach that includes biology, ecology, economics, and public policy. By studying their behavior, genetics, and environmental interactions, scientists can develop better strategies for control and prevention. At the same time, involving local communities and stakeholders ensures that solutions are practical, sustainable. While the lionfish invasion may never be completely reversed, coordinated action can reduce its impact and preserve the health of vital marine ecosystems for generations to come. Lionfish continue to expand their range, and monitoring their spread is essential to managing their impact. Their larvae, carried by ocean currents, can travel hundreds of miles from their spawning location. This allows lionfish to reach isolated reefs, deep water areas, and even artificial structures where few predators exist. In some areas, they've been found as deep as 1,000 feet, beyond the reach of most divers. This creates a massive challenge for management, as most control efforts rely on diver removal in shallower waters. Without a coordinated, large-scale effort that includes deep water solutions, lionfish populations may remain unchecked in many parts of the ocean. To understand the full extent of the lionfish invasion, scientists use a variety of tools. Satellite tagging, underwater drones, DNA sampling, and population modeling all play a role in tracking their spread and estimating population density. Genetic studies have shown that lionfish in the Atlantic possess very low genetic variability, supporting the theory that the invasion began with only a few individuals. Despite this, they have successfully colonized vast regions and adapted to different environmental conditions, from tropical coral reefs to temperate rocky coastlines. Their success highlights not only their adaptability, but also the vulnerability of ecosystems that lack natural defenses against novel predators. One fascinating trait of lionfish is their capacity for learning and memory. Research indicates that lionfish are capable of recognizing areas where food is plentiful and returning to those sites repeatedly. They also show signs of learning to avoid threats, such as divers with spears. In some heavily cold areas, lionfish have become more elusive and cautious, hiding during daylight hours or retreating to deeper parts of the reef. This behavioral shift complicates efforts to manage them through traditional hunting methods and demonstrates their capacity for behavioral plasticity in response to environmental pressures. Lionfish are solitary by nature, often staking out territory and aggressively defending it against intruders. However, during mating seasons, males become more active and visible as they seek out females. Males will display their fins, darken their colors, and even engage in brief skirmishes with rival males. When a female is receptive, the male circles her in a dance-like motion before both ascend into the water column to spawn. They release their gametes simultaneously, with the female releasing a gelatinous mass containing thousands of eggs. This rapid and frequent reproductive cycle is one of the key factors behind their population explosion in non-native habitats. The visual appeal of lionfish contributes to their popularity in the aquarium trade, but this same attractiveness has played a role in their ecological disruption. In the early days of their spread, lionfish were often released into the wild when aquarium owners no longer wished to care for them. Some of these releases were accidental, occurring during hurricanes or power outages when tanks were damaged. The lesson here is that even well-meaning actions can have unintended consequences, particularly when dealing with non-native species. Many countries now have stricter regulations on the ownership and release of exotic marine species to prevent similar invasions in the future. Lionfish. Venom is a complex mixture of proteins that causes intense pain and inflammation. The venom is delivered through grooves in the dorsal, anal, and pelvic spines, and it can remain potent even after the fish is dead. While fatalities are rare, stings can be medically significant, particularly for individuals with allergies or underlying health conditions. Treatment typically involves immersing the affected area in hot water, which helps denature the proteins in the venom. Despite their painful sting, lionfish are not aggressive toward humans and will only sting in self-defense when threatened or handled improperly. In some cultures, lionfish are now celebrated as a delicacy, with chefs creating unique dishes to promote consumption. Lionfish ceviche, tacos, sashimi, and fried fillets are just a few examples. The meat is flaky and tender with a mild, slightly sweet flavor, making it versatile for various cooking methods. By turning the lionfish into a marketable food item, communities have created a new economy centered around removal. Restaurants and chefs play a vital role in this movement, educating consumers and helping create a demand that drives harvesting efforts. Nonetheless, there is still a long way to go before lionfish are harvested at a rate that can reduce their overall numbers. Significantly, educational outreach is a cornerstone of lionfish management. Programs aimed at teaching youth, divers, fishers, and tourists about the impacts of invasive species are essential in building long-term awareness and engagement. Many dive shops now offer lionfish hunting certification courses, equipping divers with the skills to safely and effectively remove them. These courses often include information about marine ecology, invasive species management, and proper handling techniques. By fostering a sense of responsibility and empowerment among the public, these programs help turn passive observers into active participants in conservation efforts. Lionfish traps are another tool being explored to reach deeper and more remote populations. Traditional fish traps are often not selective, catching unintended species and causing bycatch issues. However, newer lionfish-specific trap designs use vertical panels and visual lures to attract lionfish without harming other marine life. These traps are still being tested and refined, but early results are promising. If proven effective and scalable, They could complement diver removals and help target areas beyond recreational diving limits. Collaboration between engineers, ecologists, and fishers is key to developing practical solutions that balance effectiveness with environmental safety. Research into lionfish ecology is ongoing, with many questions still unanswered. For instance, scientists are studying whether lionfish behavior or physiology changes depending on their environment. Do lionfish in the Gulf of Mexico behave differently from those in the Caribbean or Mediterranean? Are there differences in their diet, growth rates, or reproductive output? Understanding regional variation can help tailor management strategies to local conditions. Additionally, studies on lionfish parasites, diseases, and stress responses may uncover weaknesses that could be exploited to curb their spread. As the lionfish issue gains international attention, collaborative efforts across borders become more important. The problem is not confined to one country or region, but affects an entire oceanic corridor. Regional fisheries organizations, environmental NGOs, and government agencies are beginning to share data, coordinate responses, and pool resources. International workshops and conferences focused on lionfish provide opportunities for scientists, policymakers, and stakeholders to share best practices and research findings. This cooperation is essential for mounting an effective, long-term response to one of the most successful marine invasions in recorded history. In recent years, lionfish have been observed spreading beyond their original invasive range in the Western Atlantic. Reports from the Mediterranean Sea, especially along the coastlines of Cyprus, Greece, and Turkey, indicate a growing presence. The warming of ocean temperatures may be a contributing factor, allowing tropical and subtropical species to expand their ranges northward. The Mediterranean is particularly vulnerable because it is a semi-enclosed sea with limited inflow and a high number of endemic species. The arrival of lionfish could disrupt existing food webs and threaten native biodiversity in yet another part of the world. Lionfish have even attracted attention in the world of art and media. Their unique appearance and dramatic role in the invasion narrative have inspired documentaries, underwater photography, sculptures, and educational exhibits. Some conservation organizations use lionfish as a mascot for invasive species awareness campaigns, emphasizing the message that even the most beautiful creatures can become destructive under the wrong circumstances. Through storytelling and visual engagement, lionfish have helped bring broader issues like biodiversity loss, marine conservation, and ecosystem balance into public consciousness. In the broader context of invasive species, lionfish serve as a cautionary tale. They illustrate how quickly an introduced species can gain a foothold in a new environment, and how difficult it can be to reverse the damage once it is done. The lionfish case underscores the importance of prevention, early detection, and rapid response in managing biological invasions. It also highlights the interconnectedness of ecosystems and the global nature of environmental challenges. What began as a local issue off the Florida coast has grown into a multinational concern with ecological, economic, and cultural implications. Long-term, solutions to the lionfish problem will likely involve a combination of approaches. No single strategy is sufficient on its own. Culling by divers can be effective in high-traffic areas, but cannot reach all populations. Commercialization provides incentives, but needs scale. Technological innovations offer promise, but are still developing. Education builds public support, but must be ongoing. Coordinated, adaptive management that integrates all these elements offers the best hope of controlling lionfish and preserving marine ecosystems. Like any complex problem, the lionfish invasion demands persistence, creativity, and collaboration. Despite the challenges, there are reasons for optimism. In areas where sustained removal efforts have been implemented, Local declines in lionfish populations have been documented. Coral reefs in those areas often show signs of recovery, with increased numbers of native fish and greater biodiversity. These small victories prove that human action can make a difference, even against a formidable invader. They also offer hope that continued effort can tip the balance in favor of ecological restoration and resilience. The story of the lionfish is still unfolding, and what happens next depends largely on the choices made by individuals, communities, and governments. Will the lionfish continue to dominate new habitats unchecked, or will a collective effort succeed in managing their numbers and protecting marine life? The answer will not come overnight, but through sustained engagement, informed action, and scientific innovation, it is possible to shift the outcome. The oceans are vast, but so too is the human capacity for problem solving and stewardship. Understanding lionfish is not just about studying a single species, but about seeing the broader dynamics of life in the sea. It's about recognizing how interconnected systems are, how one small act can ripple outward in unexpected ways. Whether we're divers in the water, chefs in the kitchen, students in a classroom, or leaders crafting policy, everyone has a role to play. The lionfish may have been an uninvited guest, but how we respond will shape the health of our oceans for generations to come. Lionfish have spread so thoroughly that they are now considered one of the most successful marine invaders in history. Their dominance in the Atlantic and Caribbean ecosystems is not just a result of reproductive speed or lack of predators, but also their adaptability to various habitats. They are commonly found in coral reefs, but they also thrive in mangroves, seagrass beds, estuaries, rocky crevices, and even artificial structures like oil rigs and shipwrecks. This adaptability allows them to move seamlessly between habitats, disrupting different ecological niches and impacting a wide range of native species. One of the most significant effects of lionfish predation is the collapse of recruitment in reef fish populations. Recruitment refers to the process by which juvenile fish grow large enough to become part of the adult population. When lionfish consume large numbers of juveniles before they reach maturity, fish populations can't sustain themselves over time. This has cascading effects throughout the food web, especially for species that already face pressure from overfishing or habitat loss. Species that were once abundant have seen dramatic declines in regions with unchecked lionfish populations. Lionfish also exhibit dietary generalism, meaning they eat whatever is available. In studies examining their stomach contents, researchers have found a wide variety of prey, over 70 different species, including small reef fish, shrimp, crabs, and even juvenile lobsters. Their feeding strategy is both opportunistic and efficient. Lionfish can consume prey up to half their own body size, and they are capable of feeding multiple times per day. This insatiable appetite allows them to quickly deplete local prey populations, often leaving behind an ecological vacuum that takes years to recover from. Another concerning factor is that lionfish do not exhibit the kind of density-dependent limits seen in many native species. In most fish populations, as numbers increase, resources become scarce, reproduction slows, and natural mortality increases, keeping populations in balance. Lionfish, however, continue to thrive even at extremely high densities. This suggests that their invasive success is not likely to plateau naturally, and without active control efforts, their numbers could continue to climb, deepening their impact on already stressed reef systems. The expansion of lionfish into new areas is often facilitated by their early-stage larvae, which are tiny, transparent, and able to drift with the currents for weeks. During this time, they can travel across vast distances, allowing lionfish to colonize new territories without the need for adult migration. The high survival rate of these larvae is another factor in the explosive growth of lionfish populations. In many native fish, Larvae are highly vulnerable to predation and environmental factors. But lionfish larvae seem to have higher endurance and fewer natural threats in the Atlantic. Because lionfish are not native to the Atlantic, the local prey species have not evolved defenses against their unique hunting style. Unlike native predators that stalk or chase, lionfish use their large pectoral fins to corner prey and create confusion. Their slow, deliberate movements and sudden bursts of speed make them unpredictable hunters. Prey fish do not recognize lionfish as a threat until it's too late, and this gives the lionfish a significant advantage. Over time, this leads to naive prey populations being decimated, contributing further to biodiversity loss. Interestingly, lionfish have also been observed displaying cooperative hunting behavior, a rare trait among fish. While not fully understood, some studies suggest that pairs of lionfish may work together to herd schools of fish into tight groups, making it easier to capture prey. This behavior, if confirmed across regions, would indicate a level of behavioral complexity that adds yet another layer to their invasive success. Their ability to adapt their hunting strategies, depending on the situation, gives them an edge over more specialized native predators. Marine biologists have developed indices to measure lionfish biomass and impact in different regions. In areas where regular removal events are conducted, lionfish densities are significantly lower, and native species have a greater chance of recovering. These studies show that diver-based removal is effective, but only with sustained effort. If removal stops for even a short time, lionfish populations rebound rapidly. This means that long-term solutions require not only initial intervention, but also ongoing management, community engagement, and policy support to be effective. One of the regions that has seen extensive lionfish management is the Bahamas. Through a combination of public awareness campaigns, diver training programs, and culinary promotion, the Bahamas has reduced lionfish densities in many popular dive sites. In these areas, researchers have noted increases in native fish populations, improved coral health, and stronger reef resilience. The Bahamian model shows that coordinated community-based efforts can work when there's enough public buy-in and resources to support them over the long term. Some countries have made it legal and even encouraged for recreational divers to hunt lionfish. In the U.S., for example, certain marine protected areas have special exemptions that allow divers to remove lionfish even when other fishing activities are restricted. This is because lionfish pose a unique threat, and their removal is seen as beneficial to the ecosystem. Dive shops often offer lionfish hunting excursions, providing tourists with the chance to contribute to conservation while also having a unique underwater experience. These programs are especially popular in Florida, the Caribbean, and parts of Central America. In terms of scientific research, lionfish have become a model species for studying invasive ecology. They provide insight into how species interactions shift when an unfamiliar predator enters a new system. Their impact on food webs, nutrient cycling, and reef structure has been studied extensively, offering valuable data that could help prevent or respond to future invasions by other species. Lessons learned from the lionfish can be applied to freshwater and terrestrial invasions as well, making them a crucial case study in global biodiversity management. Despite growing awareness, many people still underestimate the lionfish threat or remain unaware of their presence. Because they are visually stunning and often appear calm, casual snorkelers and swimmers may not realize that these fish are harming the reef. Education campaigns have helped bridge this gap using signage, social media, school programs, and community events to spread knowledge about lionfish. In many coastal communities, especially those dependent on tourism or fishing, understanding the lionfish issue is vital to protecting livelihoods and ecosystems. Technology continues to play an evolving role in lionfish control. Autonomous underwater vehicles are being trained to recognize lionfish patterns and deliver targeted electric pulses to stun them for collection. These machines can work at depths and durations beyond human limits, offering a potential breakthrough in controlling lionfish populations in deep or remote areas. Although still in development, pilot projects in the Caribbean have shown that robotic removal could complement diver efforts and provide data on lionfish distribution and habitat preference. Lionfish removal contests are becoming larger and more frequent. In addition to the competitive aspect, they provide essential data to researchers tracking lionfish trends. Collected fish are measured, weighed, and analyzed to determine age, diet, and reproductive status. This data helps scientists build models of lionfish population growth and predict areas most at risk. In some contests, prizes are given for the largest, smallest, or most unusual catch, encouraging participation from all experience levels and making the events more inclusive and educational. Economic consequences of the lionfish invasion also deserve attention. As lionfish reduce the populations of commercially valuable fish, such as snapper and grouper, fisheries suffer. In the Caribbean and Gulf of Mexico, many small-scale fishers rely on these species for income and sustenance. Coral reef tourism is also at risk as degraded reefs become less attractive to divers and snorkelers. The loss of biodiversity can make reefs more vulnerable to bleaching, hurricanes, and disease, further reducing their economic value and ecosystem services. To combat these effects, regional cooperation is essential. Lionfish do not respect borders, and their spread can only be addressed effectively through collaboration. Countries sharing marine environments must align their strategies, share data, and support joint programs for removal, education, and enforcement. Organizations like the Caribbean Regional Fisheries Mechanism and various environmental NGOs are working to build these coalitions and standardize best practices across countries. The Mediterranean Sea, another area facing a recent lionfish incursion, poses new challenges. Unlike the Caribbean, the Mediterranean has cooler waters, though they are warming due to climate change. Lionfish sightings began in the eastern part of the sea, particularly around Cyprus and the Levantine Basin. Their numbers are now increasing along Greek and Turkish coastlines. If current trends continue, they may reach as far west as Italy or Spain. The introduction of lionfish into the Mediterranean underscores the global nature of marine invasions and the role of warming seas in facilitating their spread. As lionfish extend their reach, early detection and rapid response become critical. Surveillance systems that use diver reports, remote sensing, and DNA analysis can help identify new invasions before they become unmanageable. Prompt removal in the early stages is far more effective than trying to control established populations. This concept, known as eradication at the edge, focuses efforts on preventing new territory gains and limiting the geographic spread of lionfish. The impact of lionfish isn't limited to prey depletion. They also alter predator-prey dynamics. Native predators may struggle to find food as lionfish consume available prey, leading to increased competition and altered behaviors. Prey species that once relied on camouflage or certain hiding spots may find those strategies ineffective against lionfish. As ecosystems adapt to the presence of lionfish, new interactions emerge, some of which may have long-lasting consequences on the structure and function of marine communities. In the end, lionfish demonstrate how quickly an ecosystem can be disrupted by a non-native species, especially when that species arrives without its natural enemies. Their success is a reminder of the importance of biosecurity and the unforeseen consequences of human actions. Whether through aquarium releases, shipping, or climate shifts, species introductions are increasing, and proactive measures must be taken to prevent future ecological crises. Understanding lionfish isn't just about stopping an invader. It's about learning how ecosystems work, how balance is maintained, and what happens when that balance is upset. It's a story of adaptability, resilience, and the power of coordinated human effort. The more we understand lionfish, the better equipped we are to protect our oceans, not just from them, but from whatever challenges lie ahead. Lionfish have become a lasting symbol of how even a single species, introduced into the wrong environment, can trigger dramatic changes across an entire ecosystem. While much focus has been placed on their direct predation, there's also increasing interest in the subtler, longer-term effects they cause within the habitats they dominate. These include shifts in behavior of native species, reduced genetic diversity in overpredated fish populations, and structural changes to reef composition. Over time, as prey fish are decimated, predators that once relied on them may struggle to find sufficient food, leading to declining health or even local extinctions. Another issue is how lionfish interact with other invasive species. In the Atlantic and Caribbean, for instance, lionfish now share space with other non-native organisms like invasive algae or marine snails. These organisms may indirectly benefit from the lionfish invasion by facing reduced competition or predation. Lionfish, by altering food webs and grazing pressure, might create conditions that actually support the spread of other invasive species. This compounding effect is sometimes referred to as invasional meltdown, where multiple invaders together do more damage than they could alone. There's also growing evidence that lionfish can displace native mesopredators. These are mid-level predators, like certain wrasses or squirrelfish, that fill a critical niche by keeping invertebrate populations balanced and helping control small prey species. Lionfish, by outcompeting or directly eating them, can disrupt this balance. As a result, ecosystems may shift toward instability, where population booms and crashes become more frequent and harder to manage. In areas with heavy lionfish presence, reef fish behavior also starts to change. Some species may avoid certain reef structures, where lionfish tend to ambush prey. This causes those areas to become biologically empty zones, even though the physical habitat remains intact. Over time, these behavior-driven changes can alter patterns of mating, foraging, and sheltering. Coral reefs thrive on a complex web of interactions. When lionfish remove even a few strands from that web, the entire system begins to shift in ways that are difficult to predict and nearly impossible to reverse. Marine Protected Areas (MPAs), which are established to safeguard biodiversity, are not immune to the lionfish threat. In fact, they may unintentionally become safe havens for lionfish if removal efforts are not prioritized. Many MPAs restrict fishing and spearfishing, which limits what can be done to control lionfish inside their boundaries. However, some regions have begun granting special permissions or exemptions to allow lionfish culling in protected waters. This has been a necessary adaptation, acknowledging that protecting biodiversity sometimes requires active intervention, not just passive preservation. In terms of physiology, lionfish have few weaknesses. They can tolerate a wide range of temperatures, salinities, and depths. Studies have shown them surviving in waters ranging from 50 to 95 degrees Fahrenheit and in environments with fluctuating salinity such as estuaries. This physiological flexibility allows lionfish to survive in areas many reef species cannot, including colder, deeper, or more nutrient-variable waters. This is one of the reasons their spread has been so difficult to contain. Barriers that would restrict other species have little effect on lionfish. Lionfish also appear to have a resistance to many local parasites and diseases. While native fish often suffer from infections or parasites that help keep their populations in check, lionfish remain comparatively unaffected. This biological advantage means they suffer lower mortality rates, and their populations grow faster. As a result, Some researchers have theorized that their skin mucus may have antimicrobial properties, but more research is needed to confirm whether this trait offers a specific edge in invaded ecosystems. Reproductive maturity in lionfish occurs early, sometimes in less than a year, and individuals continue to spawn regularly throughout their lives. Unlike many native species that have seasonal reproduction tied to environmental cues, lionfish can reproduce year-round. This is particularly problematic because it means there's no natural seasonal break during which management efforts can reset the ecosystem. The steady influx of new juveniles creates a constant pressure on prey populations and makes it harder for other fish to rebound between lionfish generations. Despite the scale of the invasion, coordinated response efforts have shown that lionfish can be controlled in targeted areas. Removal programs that focus on popular reefs, tourist zones, and fish spawning areas can help maintain ecological balance in those key locations. Even if complete eradication is unrealistic, localized suppression can keep lionfish numbers low enough to allow native species to survive and reproduce. These managed areas can act as refuges or reservoirs for biodiversity, helping support the health of surrounding reefs that may be more heavily affected. Public engagement remains one of the most powerful tools in the fight against lionfish. Communities, NGOs, research institutions, and even fishermen have collaborated to raise awareness, organize events, and share information. Online platforms now exist where divers can report lionfish sightings, upload removal data, and help scientists track changes in distribution. Social media has played a role too, making lionfish both a villain and a rallying point for ocean conservation. Memes, videos, and infographics help distill scientific information into accessible messages that reach wide audiences. Another promising avenue is culinary integration. As more chefs discover lionfish, demand for the fish is growing in restaurants and markets. Initiatives such as Eat M to Beat M campaigns promote lionfish consumption as an environmentally responsible choice. Some grocery stores and seafood markets have started selling lionfish fillets, while food festivals sometimes host lionfish cook-offs. These efforts help support a removal economy, turning a major ecological threat into a manageable food source, all while educating consumers about the problem. Still, lionfish are not an endless resource. Relying solely on commercialization risks sending the wrong message that lionfish will always be plentiful or that harvesting alone is enough. To be sustainable, commercial use must be paired with conservation messaging and not replace the need for broader ecological management. Restaurants that serve lionfish often include information about its invasive status on menus, which helps maintain the focus on why eating lionfish matters. Children's education programs have also expanded to include lionfish-specific content. These range from classroom lessons to hands-on dissections and snorkeling trips. By involving youth, communities create future generations of ocean stewards who understand both the science and the cultural importance of marine conservation. In coastal regions where fishing and tourism are central to the economy, these programs can help preserve livelihoods while building environmental awareness. In the realm of policy, some countries have begun creating regulatory frameworks specifically for managing invasive marine species. These include permits for lionfish hunting in protected zones, funding for removal efforts, and legal pathways for marketing lionfish products. Some regions are also updating laws that prohibit the release of aquarium species into the wild and adding lionfish-specific provisions. These legal tools are crucial for ensuring that control efforts are both effective and consistent. Across jurisdictions, art and culture have embraced lionfish as well. Sculptures made from lionfish spines, paintings inspired by their patterns, and documentaries showcasing their story have all helped make the issue more relatable. Storytelling, whether through art or film, can reach audiences who might never read a scientific paper or attend a dive conference. These creative approaches are key in building empathy and motivating action. Also provide valuable lessons for early detection and rapid response, EDRR, strategies in marine environments. Their dramatic spread has led scientists to refine surveillance methods, improve data sharing between agencies, and develop faster response plans for new invasions. These lessons have broader implications for managing other marine invaders, such as certain jellyfish, algae, or crab species that are starting to expand their range due to global shipping and climate change. Another strategy being explored is habitat manipulation. Because lionfish prefer certain types of reef structures and hiding places, some researchers are testing whether artificial reef designs can discourage lionfish colonization while still supporting native species. Others are examining how marine noise pollution, temperature fluctuations, or predator cues might be used to alter lionfish behavior. While still experimental, such strategies could become part of a multi-pronged management approach in the future. As technology evolves, genetic tools may eventually play a role. Environmental DNA, eDNA, is already being used to detect lionfish presence in new areas by sampling water for genetic traces. Looking further ahead, genetic engineering has been proposed as a potential solution, introducing a genetic element that reduces lionfish fertility or biases offspring sex ratios. However, this comes with ethical and ecological risks and would require significant research and international agreement before being deployed. Ultimately, the story of the lionfish invasion is still unfolding. It challenges us to think more deeply about how ecosystems respond to change, how interconnected global trade and local biodiversity really are, and how we as humans can shape the health of our planet's oceans. While lionfish are here to stay in many places, their impact does not have to remain unchecked. Through a mix of science, policy, community action, and innovation, the damage can be mitigated and many reefs can still be protected or restored. Invasive lionfish populations have driven researchers to rethink how we monitor and manage marine ecosystems. Traditionally, monitoring reef health involved visual surveys and occasional sampling. But with lionfish spreading so rapidly and unpredictably, new tools have become essential. Environmental DNA, or eDNA, is now being used in some regions to detect lionfish in areas where they haven't yet been visually confirmed. This method involves analyzing water samples for genetic traces left behind by marine organisms. It's fast, efficient, and particularly useful for early detection in remote or deep water habitats. Early detection allows for faster response, but rapid response also depends on having people, funding, and tools in place. Some countries have started implementing rapid response protocols, specifically for lionfish, which means when a new sighting occurs in an unaffected area, trained divers and removal teams can act immediately. This is especially important at the edges of their current range, where preventing establishment is still possible. In places where lionfish populations are already entrenched, management focuses more on suppression than eradication, targeting key habitats like spawning grounds, nurseries, and reef fish HOTSPOTS. The importance of consistent and repeated removal cannot be overstated. Studies have shown that a single lionfish removal event, even if it clears an entire reef section, is only temporarily effective. Lionfish quickly recolonize those areas, sometimes in a matter of weeks. Effective programs schedule regular removals every few weeks or months, depending on the location. This frequency is necessary to keep lionfish numbers low enough that native species can survive and reproduce without being wiped out between efforts. Even though lionfish have few natural predators in the Atlantic, some native species have shown signs of beginning to interact with or even prey on them. Groupers, moray eels, and sharks have occasionally been seen eating lionfish, especially when they are already wounded or cornered. However, this is rare and inconsistent. It's still unclear whether these predators recognize lionfish as prey in the wild without human interference. Some have proposed conditioning predators to associate lionfish with food, but doing this safely and effectively across broad areas remains a major challenge. Artificial reefs have become both a blessing and a curse in the lionfish story. On one hand, they create new habitat that supports fish diversity and gives divers access to removal sites. On the other, they often become lionfish hotspots, especially in deeper waters where natural predation is even lower. Lionfish prefer complex structures with lots of hiding spots, which many artificial reefs provide. Managing these sites effectively requires regular monitoring and a coordinated effort between conservationists and dive operators who frequent them. Lionfish behavior is also evolving in response to pressure. In heavily cold areas, lionfish have begun hiding deeper in reef crevices or emerging mostly at night. Some researchers believe that lionfish are learning to avoid certain diver behaviors or tools, especially spears. This kind of behavioral adaptation makes removal more difficult over time and forces divers to adjust their techniques. It's another example of how dynamic and challenging invasive species management can be when the species in question is intelligent and adaptable. Despite their ecological harm, lionfish continue to fascinate people. Their striking appearance bold, stripes, elongated spines, and fluid movements makes them visually iconic. Underwater photographers and videographers are drawn to them, and many use their imagery to educate others. These visuals help explain the lionfish issue to those who might never go diving themselves. Beautiful, high-resolution images paired with conservation messaging have proven effective in raising awareness and inspiring action around the world. The economic side of lionfish management is growing. Commercial fishers are beginning to include lionfish in their regular catch in some parts of the Caribbean and southeastern U.S. coast. Processing centers are learning how to safely handle and debone lionfish, while restaurants are discovering new ways to prepare and serve them. The added costs of careful handling and spine removal mean lionfish meat is often priced higher than other local fish. But many consumers are willing to pay for a product that supports conservation. To further reduce handling risks, some processors use specialized gloves, shears, and cleaning stations to remove the venomous spines before fish are sold or cooked. Once cleaned, lionfish meat is completely safe and venom-free. The spines contain the venom, not the flesh. This is important messaging in educating new markets. Many people mistakenly believe lionfish are toxic to eat, when in fact, they're perfectly safe and even considered a delicacy when prepared well. The rise of lionfish cuisine has led to creative culinary competition. Chefs compete to develop new recipes and cooking methods, from grilling and frying to using lionfish in sushi, ceviche, and tacos. These events attract media coverage and public interest, especially when tied to larger conservation efforts. Food festivals centered around lionfish now occur in several coastal cities, serving as both outreach opportunities and practical tools for increasing consumer demand. Meanwhile, research continues into lionfish biology, genetics, and ecology. Scientists are studying lionfish at every stage of life, from egg to adult, in order to understand what makes them so effective as invaders. One area of interest is how lionfish larvae survive and disperse. Their long larval phase and rapid development give them a significant edge. Genetic studies are also exploring whether different populations of lionfish are beginning to diverge as they adapt to local environments. Such findings could help tailor control methods more precisely in different regions. Education remains a top priority. Many marine biology programs now include invasive species as a core component, using lionfish as a case study. Outreach materials, classroom guides, and interactive websites help teachers introduce the lionfish story to students. By linking marine science to real-world environmental problems, educators can engage students in deeper discussions about human responsibility, ecosystem balance, and what it means to protect biodiversity in a changing world. Tourism industries are also getting involved. Dive shops offer lionfish hunts, eco-tours highlight their impact, and local guides incorporate lionfish facts into their talks. Some tour operators even provide spears and training so that certified divers can participate in removal events during excursions. This form of conservation tourism blends recreation with impact, giving tourists a chance to help while exploring the underwater world. Still, lionfish control faces serious limitations. Remote reefs, deep zones, and under-resourced regions may go months or even years without any removal efforts. These areas can serve as breeding grounds, replenishing nearby zones that have already been cleared. Until better tools exist to reach these places efficiently, lionfish will continue to repopulate faster than divers can remove them. This is why scalable solutions, traps, robots, or automated harvest systems are a high priority for ongoing research. Policy efforts are expanding to match the scope of the problem. Some countries are working on regional lionfish management plans that include funding for research, enforcement of trade restrictions, support for fishers, and investment in public education. International cooperation is also improving. Data sharing, networks, and multi-country workshops help align strategies across national boundaries, especially in areas like the Caribbean, where fish populations migrate freely. The lionfish invasion has also reignited debates around the global aquarium trade. Critics argue that stronger regulation is needed to prevent future releases of non-native species. Proposals include tighter import restrictions, public education for aquarium owners, and better disposal options for unwanted pets. While lionfish were the result of past actions, they serve as a warning about what can happen when exotic species are released into the wild without proper foresight. Ultimately, the story of lionfish is not just about a fish, it's about ecosystems, decisions, consequences, and resilience. It's a story that teaches the importance of vigilance, the risks of inaction, and the power of collective response. Whether through diving, cooking, studying, teaching, or organizing, individuals can play a meaningful role. And while the fight against lionfish may not end soon, every reef protected, every fish saved, and every person educated is a step toward restoring balance. The lionfish invasion is a stark reminder of how fragile and interconnected our oceans truly are. But it's also a story of resilience, innovation, and community action. While we may never fully erase their presence, we can choose how we respond through science, education, and sustainable action. Every dive, every meal, every informed decision counts. The fight to protect our reefs isn't over, but with collective effort, it's a fight we can still win.